Hey, welcome back. Let's get into something that's incredibly powerful in Unreal Engine shader development. If you're working with materials, you have to try the custom node. It's a material expression. If you ever hit the limits of what standard material nodes can do, this is your way out. The custom node gives you direct access to HLSL right inside the material editor. It's basically shader programming without leaving the material graph. What is the custom node? Let's start simple. The custom node is like a programmable node. You type in HLSL code, Unreal compiles it into shaders, and you get full control over what it does. It's not just a novelty. In many cases, it's the way to get performance improvements, cleaner graphs, or effects that just aren't possible with normal nodes. So if you're doing complex math, want to reduce visual clutter, or need to tap into GPU level features, this is the tool for the job. Why use custom nodes? Here is where they shine. Efficiency. If you're performing heavy math, a few lines of HLSL are often faster and lighter than a huge tangle of nodes. Cleaner graphs. Instead of spaghetti mess of wires, you can wrap logic into neat node. Advanced shader features. You can use GPU features that just aren't exposed in the material editor otherwise. Reusability. With the right setup, you can reuse functions and reduce duplication across your graph. This isn't just about doing cool things. It's all about keeping your materials scalable and performant. How it works. When you drop in a custom node, the Details panel gives you a few important fields. Code. This is where you write your HLSL logic. Output type. You set this to match your code returns. Float, float tree, etc. This has to match exactly or the shader will fail to compile. Description. Optional but useful for documentation. This one shows up above the node in your graph. Include file path. Here you can attach files to access their variables and functions. Additional defines. You can define some preprocessor variables here, like constants. You can add inputs to the node via the plus icon in the Details panel. Each input needs a name, which becomes your HLSL variable. Same for the output. You can define multiple outputs given a name and its type. Once configured, the I/O pins will respectively show up. Let's look at some examples. Example 1. The dot product. Let's start small. Set output type to float and add two inputs, A and B, both float 3. That's it. Example 2. Time-based effects. Want something dynamic? Let's do it with sine and cosine using the time node as an input. See? And now you got a pulsing effect. Again with one line of code for the effect and with another a speed multiplier applied. Example 3. Twisting vertex normals. Now for something more advanced. Let's say you want to twist vertex normals based on position. Something difficult to do with standard nodes alone. You add inputs like twist amount, float, and twist center, float 3. And use HLSL to calculate position offsets and rotate the normals. Here's a simplified version of what code might look like. With that, you're deforming mesh shading in ways that would be messy or even impossible to do with regular nodes. Things to keep in mind though. Using custom nodes is powerful, but there are trade-offs. Performance. Done well, they're faster than nodes. Done poorly, they're worse. Debugging. No visual node part means you will have to output intermediate values, like to emissive color to debug. Portability. Stick to standard HLSL if you want cross-platform support. Maintainability. Comment your code. You will forget what it does in a week, so will your teammates. Also, material functions are often better when your logic doesn't require HLSL, so reach for custom nodes when you really need that extra power. The custom node isn't just a niche tool, it's a direct line to the GPU and gives you capabilities far beyond what the visual graph offers. If you know a bit of HLSL or willing to learn, you will be able to solve problems faster, write cleaner materials, and unlock effects most developers don't even try. Explore it, experiment with it, and see where it can take your visuals. Thanks for watching, and I will see you in the next one.